We start off with the same simulation file as was shown in the demonstration for the index monitor, which contains a photonic crystal cavity resonator made of a dielectric slab with a pattern of holes etched into the slab forming the cavity. Symmetry is used in the simulation region in the X and Y directions to reduce the memory requirements. Here we want to add a time monitor to measure the resonant fields of the cavity and look at the spectrum of the fields to determine the resonant frequency that's excited. Add a time monitor from the Monitors drop-down menu of the main toolbar. Edit the monitor and set the start time to 75 femtoseconds. This sets the time at which the time monitor starts measuring field data. By delaying the start time, I can avoid measuring the initial source pulse which excites the resonance of the cavity, and only measure the resonant fields of the excited mode. This means that in the spectrum result that I'll plot later, it won't include the spectrum of the source pulse, only the spectrum of the resonant modes. In the Geometry tab, set the X, Y, and Z position of the point monitor to 0.1 microns. The reason to offset the position of the monitor from the center is that sometimes the resonant mode will have a node at the center, meaning that the fields of the mode are 0 at the center. Offsetting the position where I measure the fields can reduce the chance that the monitor won't record any resonant fields. Run the simulation. After the simulation has completed, right-click and visualize E, which generates a plot of the electric field amplitude over time. I can see that the time starts at 75 femtoseconds, so I don't see the signal of the source pulse, and I can only see the decaying resonant fields of the cavity over time. Next, right-click and visualize spectrum. Here I can see a sharp peak at around 0.5 microns. If I zoom in and hover over the data point at the peak, I can see that it's around 0.478 microns. Now that we've seen a demonstration of the setup of the time monitor, let's go over some setup tips. We can set the recording time to include only the time window that we're interested in. Like in the example that we just saw, we were able to exclude the fields due to the initial source pulse and only record the resonant fields of the cavity by setting the start time for recording. We can plot the fields over time to check that the fields have decayed by the end of the simulation time. In the previous simulation, we also used it to check that the start time that we set was late enough that it didn't include the source pulse. To be able to get the spectrum result, which is a Fourier transform of the time domain data, the time monitor type must be a point monitor. If you want to get the spectrum at multiple locations, you can use multiple point time monitors. Using point monitors is also more efficient in terms of memory compared to using 2D or 3D monitors.